This lesson is going to tell you about time series and sampling. Now, time series are a type of graph that you may not have come across before, but they're actually not too complicated. And then tied in with that, and to sort of finish off some of our work in the data handling section, we're going to look at different ways of sampling data and then what's good about one way versus what's not so good about that way. So we're going to discuss some of those. This ties in with chapter 16.4 in your GCSE textbook. Okay, so let's have a look at time series graphs first. Now, you don't need to draw this one down, but in the top corner here is an example of a time series graph. So you can very quickly look at what's plotted on the axes. It's got a title, room temperature. So what they've done is they've taken some room temperatures, temperatures of a room over a certain period of time. They've recorded them and then they've plotted them on this graph to make points, and then they've joined them together with a line. Now, this is an example of a time series graph. Okay, and basically a time series graph is any graph which has a scale that is to do with time is called a time series graph. Okay, so it's nothing more complicated than that really. It's just a graph that is to do with time and to do with recording something over a period of time. Now, if you're asked to draw a time series graph, then you always plot time on the x-axis or on the horizontal axis. So that's an important thing to note. I would say make sure you're writing these key facts down in your notes. So time always plotted on the horizontal or x-axis. Sometimes, depending on the data that you're presenting, you don't necessarily need to start the axes at 0. You can see for this particular graph, they don't start at 0. Remember, what we generally tend to do if they don't start at 0, we put one of our little zigzags in. That's what I would generally do here. They just haven't in this particular example that I've cut and pasted. Okay, now what are time series graphs good for? Well, you can plot the data, you can join them together with lines, and you can look at how that data is varied. Now, because the data is plotted on the graph according to a time period, you can look at trends, so you can look at what's happening over a period of time. And sometimes you'll see some of the ones we look at might be plotted over a monthly basis, so you can also look at seasonal variations for the data that you're given. It can be used for discrete or continuous data, so basically as long as you have a measurement that you can plot, then that's fine. It shows every piece of data, so when you've recorded that information, you plot it on your graph and then you can join them together with lines. And that's usually what you do. It's a line graph, so you plot your points and then you'll join them together with some lines, because that shows nice and clearly what's happening as far as the trend or as far as variations go to do with that set of data. Okay, so we're going to have a look at a couple of examples. Now, do make sure you've got pencil and a ruler, because we're going to be drawing some graphs. So here's the first example, and here is the table of values. Okay, so you will need to please draw those table of values. Okay, so copy them down into your notes. If you need a bit of time to do that, then just pause the video while you do that. And let's just have a look at the data. So this is data that's collected over a whole year on a month-by-month basis. And it's average monthly rainfall, okay, average monthly rainfall in Sheffield, okay, over that period. Well, it says over the last 30 years, so they would have collected data for January over the 30 years and then averaged it. Okay, rainfall in centimetres. So what it says is to draw a time series graph. Okay, so once you copy those values down, have a little think about what your graph's going to look like. Remember what I said about where you put the axis that represents time. That always goes on the x-axis or on the horizontal axis. So then the vertical axis will be for rainfall. Now, if you look at the values for rainfall, okay, the smallest value that you're going to be plotting there, the smallest one, if you look at them, is 5.1. So I think really to be able to show what's happening, it would make sense to not start your vertical axis at 0, but maybe start it at 5, just so you can see the variation in them a bit clearer. Okay, so this is what your graph's going to look like. Here's one I prepared earlier. So all decent graphs, they have your axes. You have your axes labelled as to what they represent. So rainfall there, month there. Okay, they've summarised them just with the initial letters, just to make it a little bit easier to write on there. Look at what we've got here as well. Okay, this is what I'd like you to put on your axes when you don't start them at 0. Just a little wiggle there means that it doesn't start at 0. So you can see starting and going 5, 6, 7, 8, 9, 10 like that shows you, make sure you have a decent scale so that you can see the variations in. So I've plotted my points, so you can see for January 8.7, February 6.3, March 6.8, etc. I plotted them as crosses, which is what you would normally do, and then I've joined them together. Please use pencil and ruler, join them together with some straight lines, and you can see that it shows the variation quite nicely there as to what's happening with the rainfall, average rainfall throughout the year. Now this question doesn't ask you to comment on it, the next one will, but if we were asked to comment on it, you can see what's going on there is that the rainfall tends to be less in the summer months, okay, and more in the winter months and into the autumn as well, with the most being over the winter months. So if you were asked to comment, you would say something like that. Okay, so that's your first example of a time series graph. If you need a little bit more time to write that down, okay, then please do pause the video now, because we're going to go on to the next example. Okay. Here's example number 2. So it's Jenny's quarterly gas bills over a period of 2 years are shown in the table. Okay, so what they've done there is they've given you, if you're aware that when you pay bills, they're normally paid quarterly. Okay, so quarterly means 4 times a year. So this would be the amount they pay for the January to March quarter. This would be the amount they pay for the April to June quarter, July to September, October to December. So plot the data on a graph. So this is going to be a time series graph because one of the axes represents time. And what we're going to do is we're going to plot it for 2003 and 2000 and on to 2004 in a continuous graph. So your axes are going to look like this. So if you look at what's in along the x-axis, which is where your time goes, again, they've just abbreviated the quarters because otherwise it can get a little bit busy on that axis if you try to write January to March. Okay, nice and evenly spaced out along there. They've also said which is 2003 and which is 2004, which is useful. On the y-axis, again, when you're drawing yours, please put your little zigzag in here. They haven't done it there, but I would certainly make sure that I have a zigzag in here because it doesn't start at 0, so there should be a zigzag before your 20. Okay, and that just makes sure that you spread out your axis nicely so your graph isn't all grouped together in the top section of your graph or of your axes. Okay. So you can see where we've plotted the values. So for 2003, January to March 65, so that's your cross here. Okay, continue to plot them all and join them together again with a straight line. So this question says, comment on any pattern in the data. Now you do want to make sure, if this was an exam question, you do want to make sure that you're going to get all of the marks for this. So there's 2 different things to comment on here. Firstly, there's commenting on the variation throughout the year. Now, a bit common sense here. You think about what you're going to use gas for. It's going to be a lot for heating. So you can see over the course of the year, it's a lot. You pay a lot more money for gas in the winter months, and then it drops down in the summer months. Okay, so that's one thing you're going to comment on. The other thing to comment on is what is changing from one year to the next. And if we do compare some corresponding values, for example, this is the July to September for 1 year. This is the July to September for the next year. We can look at a different one. This is the April to June for 1 year. This is the April to June for the next year. And you can see from 2003 to 2004, those are increasing, which again is probably what you would expect, because when you've got from 1 year to next, normally the gas board or the gas company will increase their values, increase their tariffs over the course of the year. So that's kind of what you would expect to see. Okay, so here's the comments that I would expect to see written down for this. Okay, so make sure you write both of those down underneath. In an exam, this part of the question might be worth 2 marks. So if it's 2 marks, make sure you say 2 things. So just to clarify, 2 things to comment on: what's changing over the course of 1 year, and then what is the comparison from 1 year to the next. That's going to get you all of the marks for that question. Okay, so really that's all we're doing on time series graphs. They're not particularly complicated. All they are is graphs that have data that is to do with time. So that's all you need to remember if you ever see something to do with time series graphs. Okay, second half of the lesson then we're going to look at sampling. Okay, don't need to write these down, but these are some of the vocabulary or the words that you need to understand to do with sampling. Okay, so by the time we've been through all of this, you will understand what all of these mean. So there's population, census, sample, biased versus representative. Okay, so that's all to do with the sampling. We're going to look at some different types of sampling. So there's random sample, stratified sample, survey, and then there's different types of data. There's primary data and secondary data. So you need to understand and know what all of these things mean, because they might turn up in a question to do with the wording. So you've got to know what you're reading. Okay, so notes to make on sampling then. All right, so make sure you write the title underneath sampling. Okay. Some of these words you will know what they mean, but some of them might be new to you. So I would copy down everything that's coming up on here. If you've got a highlighter or a different colour pen, then the words in colour are your important keywords. So maybe you highlight those or you underline them. So when you do a survey, you have to choose what data you're going to collect. Now, if you basically collect all of the data, okay, then that is called the population. All right, so if you collect all the data, that is called the population. There we go. Okay, now if you do collect all the data, then that's called doing a census. So occasionally in this country they have a census where they will collect certain pieces of information to do with the whole population of this country, and that is called a census. As a school, we have to regularly do a census which covers the entire pupil population within our school. Okay, so that's basically collecting all of the data. Now you can understand, this has popped up already, you can understand that doing a census is very time consuming because you are collecting a large amount of data across everybody. So better than that is for you to take a sample of the population and use that for whatever statistical analysis that you want to do. Now, what you've got to make sure when you collect your sample is that your sample is actually representative of the population. Okay, so if you collected a sample, so say if I was sampling, collecting data to do with some information on year 10, but I only chose people from 10J, I would be being biased because I would only be selecting from one tutor group. Okay, so that would be biased and that would be not representative. Okay, to be representative, you would want to make sure that you select people from each tutor group. It's to make sure the data is sort of fair, okay, and represents the people that you are collecting data from. Okay, so that's about being biased, okay, rather than representative. Okay, now on that initial list of keywords, there was also about primary data and secondary data. So primary data, if you are taking a sample or collecting data, primary data is you have physically collected the data yourself. Now, sometimes that's possible. You might do a questionnaire, or you might go out on the street and survey people. But a lot of the time, if you're doing something to do with, say, average rainfall or something like that, you're not going to go measure the rainfall yourself. What you're going to do is you're going to go onto the Met Office website probably and get some information from there. If you do that, that is called secondary data, because it's data you are using, but you did not collect it yourself. Okay, so make sure, writing all this down, make sure you understand the difference between primary data, which you have gone and collected, maybe with a questionnaire, okay, and secondary data, which is you've got it from somewhere else, you might have got it off the internet, okay, and that's data that's been collected by someone else. Now, assuming that we want to do a sample, then how we're going to do that is we're going to do that by sampling the data that's available to us. Okay, so there's 3 main sampling methods. Okay, and what you want to make sure is that your sampling methods aren't going to give you biased data, they're going to give you representative data. Okay, so here are the 3 main sampling methods that you need to know. Okay, first one. First one is just called random sampling. Okay, and that really is just picking, say if you're surveying people, just picking people completely at random. Now, sometimes in an exam question on sampling methods, they might say, how could you do that? How could you collect that data? So there are a number of different ways of doing it. Okay, but as good as any is to allocate people a number, okay, and put them all in a hat and then just pick them out randomly. Okay. Another method is there is a random number generator on your calculator. You can use that as well to pick people, but it's basically completely picking at random. Now, if you have a think about that, that may produce a representative sample, but it may not. If I numbered all of year 10 and put all of your numbers in a bag and I picked them out, I could possibly pick out a lot more people from one tutor group than from another. So suddenly it becomes biased and not representative. So although random sampling is a very easy method to do, it also is potentially produces a biased sample. Second method, systematic sampling. So as you can imagine, it's got the word system in it, you are using a system to collect your data or to choose people. Okay, so this might be, rather than putting the numbers in a hat and picking them out, which is completely random, you're going to pick every 10th person in a list once you've numbered them. Okay, so you're using some kind of system. So again, depending on how you number them, that could possibly produce a biased sample, could possibly be not representative, because there's an element of you just picking according to a system and you don't really know what you're going to get with that. Third and final method is called stratified sampling. Now, this is by far the best method, and this is the method that will give you a representative sample. Because what you do is you basically group your data according to certain criteria. It might be boys and girls, it might be people in different year groups, it might be to do with professions, anything like that, you can group them. And then you pick in proportion to how many there are in each group. Okay, so if it was according to boys and girls and there were 1/4 girls and 3/4 boys, then if you were picking 20 people, you would make sure you pick 1/4 of those 20 people as girls and 3/4 of boys to be representative of the population. Okay, so stratified sampling is the best because it is representative, okay? But it takes more time to do. Yeah, it's just slightly more complicated in that you've got to work out how many to pick from each section, and then you've also got to number those and pick them as well. Okay, so that's your three main ones that you need to know. Okay, this one is simple, but can be not representative. Okay, systematic again. It's got a little more behind it, but that could end up not being representative, whereas stratified is the best one. Okay, so let's have a look at just making sure you've understood how those work. Okay, so here's a population of 12 smiley faces, and we want to sample 4 out of 12 of those. So if you were asked how you would do that randomly, what you would do is you would number them 0 to 11, put those numbers into a hat and pick out 4 of them. Okay, and then you use the 4 smiley faces that correspond to the numbers you picked out. Okay, now you can see within our group there we've got some yellow ones and we've got some purple ones. You could, with random sampling, you could pick all yellow ones, okay, and that may not be representative. Okay, so although it's very easy to do, you might not get a representative sample. Systematic sampling then. Let's use some sort of system to select them. So we need 4 people, so let's pick every 3rd person. So we pick number 2, okay, number 5, number 8, and number 11. And again, look at that though. Look at the ones that we've picked. Just because of our particular system that we've used, we've picked all yellow faces. So that sample is not representative of the population. Okay, so that would be a biased sample, especially if yellow and purple people had different views or different opinions on something. So let's have a look at our stratified sampling then. Again, we've got the same 12 people there. What we do for stratified sampling, so this is making sure that you understand this, is we pick the number of people in proportion to how many of them are in the population. So if we have a look at our 12 smiley faces, okay, 3 of them are purple, so 1/4 of them are purple, and 9 of them yellow, so 3/4 are yellow. So when I need to pick 4 people, we want 1/4 of those to be purple and 3/4 to be yellow. Okay, so I want to pick 1 purple person and 3 yellow people. Okay, and that's going to be my stratified sampling. The question might then say, go on, how would you do that? Okay, well what I'd do is I would number my purple ones 1, 2, and 3. I would randomly pick one of those. I would number my yellow ones 1, 2, 3, 4, etc. 5, 6, 7, 8, 9. And again, I would randomly pick 3 of those to give my ones that I want to use for my sample. Okay, hopefully that all makes sense. So here's final example, and this will definitely be representative of the population because we have chosen in proportion to the number of people in each of those groups. One last example that I would like you to write down, because this is the kind of style of exam questions that you get. So if we have a look at what we've got here, we've got a table of information to do with the quantities of boys and girls in year 7 and in year 8. Okay, so please copy that table down, pause it if you need to. Okay, always look back in the question. We want to survey 20 pupils. Okay, so how many, how are we going to choose the ones we want to survey? Now, if we did a random, we could just number all of those 300 people, 300 students, and we could randomly pick 20. But you can see the problem with that. I could end up with all boys from year 8, because if I pick 20 people, they could all be in this one here. So what I'm going to do is we're going to do a stratified sample. Okay. So what we need to do is we need to work out how many we're going to pick from each of the different groups. Now the different groups, there's 4 of them. Year 7 boys want to be represented, Year 8 boys want to be represented, Year 7 girls and Year 8 girls. So I want to pick in proportion to the numbers that are in there. So let's see how we can work out how many we need to pick. Well, let's look at the Year 7 boys first. Okay, we want to know what fraction of the total number of pupils is Year 7 boys. So take a moment to think about it. Well, there are 70 of them and there are 300 in total. So that is the fraction of the population. Remember, the population is all the data. That's the fraction of the population that is Year 7 boys. Now, I want to survey 20 pupils, so I want that fraction of the 20 pupils to be Year 7 boys. Pop that in your calculator and it comes out as 4.6 recurring. Now, I can't pick 4.6 boys, okay, so I would round that up to 5. So I would pick 5 from the Year 7 boys. So I'd number those 70 boys and I would randomly pick 5. Okay, let's do Year 7 girls next. Now you should be able to finish doing all of these. Let's do the same thing. Year 7 girls, what fraction are Year 7 girls? Well, there's 50 out of 300. That's the fraction of Year 7 girls. And I want that fraction of the 20 to be Year 7 girls. Again, pop that in your calculator, 3.3 recurring. I had a recurring on. I can't do 3.3, so I round that to 3 from that Year 7 girls. So again, I would take the 50 Year 7 girls, I would number them 1 to 50, and I would randomly pick 3 of them. Final 2 then, Year 8 boys. What fraction are Year 8 boys? 100 out of 300, or a third. So I want a third of the 20. Remember in maths, of means times, okay? Third of the 20. So that is 6.6. I can't pick 6.6, so I'll round it up to 7. And then the final one, Year 8 girls. Okay. How many Year 8 girls are there? 80 out of the 300. And so I want that fraction of the 20 to be Year 8 girls, and that comes to 5.3, or I round that to 5. Okay, so those will be my answers. Let's just do a really quick check that I haven't made any mistakes. Have a think how you could check. Well, I want 20 in total, so I had better make sure that they add up to 20, and I can see, yes, they do. Okay, so that is how I would allocate out how many to choose from each of the categories, and then to actually choose them, I would number, for example, these, I would number 1 to 70, and I would pick 5 of them. Okay, so hopefully you've understood that, and you can appreciate how doing the stratified sample, it takes a bit more work, but it will always be, remember what the word is, what we're looking for our sample is we want it to be representative of the population. Remember what the population is? The population is all of the data. Okay, right, it's over to you then. 2 separate bits of work to be done. Exercise 16.4a, that is an exercise on your time series graphs. So there's 2 graphs I want you to draw. So page 331, questions 3 and 5, you just need to draw 2 graphs, and then it asks you to comment on the patterns. So a little bit like we did when we were looking at the gas bills one earlier on. Don't want that submitted, so just do it in your books, please. Check your answers from the back of the book. Now this is the bit that your teachers will be able to see. I'm going to set on My Maths a sampling online homework, so that's linked to the second half of the lesson there. If you do struggle, go and look at the online lesson, but you will actually notice that a lot of the things that were in my lesson I have actually got from My Maths, so it should look quite familiar, but do use that to help you if you need to. So do make sure you do that homework. It will be there on My Maths for you. Do the homework, make sure you check it in, okay, and then that will be done. Okay, just a word to say about working in your maths books. If you do run out of space in your maths book, okay, there are some maths books available in the school reception. So if you do have somebody from your family that's out and about, reception at school is open, okay, from 9 until 1 every day that school is open. Okay, so if you want to send somebody in to get you a new maths book, then please do. Either that or just find yourself some other squared paper, especially if you're doing graphs. Okay, lovely. That's it then. So that's over to you. So thank you very much.